So the log expressions get harder. And then we're going to solve log equations. We never actually had one yet, where you have to solve for x. And x is going to be all over the place, not just in the base, that like it says here, but x could be all over the place. All right, so let's make sure you get the basic stuff before we go on to these slides. Let's make sure you get a basic one. What if I said log base m of p equals L? You should be able to turn that into an exponent equation. An equation that has an x in the exponent. Technically, we want an exponential equation. Usually it's an x in the exponent. In this case, there isn't an x. So your equation starts with m. If you're not doing that right, then check yourself. Starts with an m. All right, compared to the kid next to you, straight across from you. See if we get the same equation as them. You should have said m to the L equals p. Raise your hand if you had that one right. Awesome. That is just a rearrangement of this, and it doesn't have a log in it. See, sometimes the challenge is to get the log out. Sometimes you need to get the problem to have a log in it to be able to solve it. So like when I gave you the very first one, I always say 5 to the x equals 8 because I think it's a good example. And you're like, oh, 5 to the 1 is too small. 5 to the second is too big. Must be like 1 point something. And then you have to have logs to solve this one. It would be log base 5 of 8 equals x. Now this is really important. Do you see how it goes around like this? I call that the circle of logs. Because in a minute, it's going to get more confusing. Maybe the x is going to be here, and this will be a y, and this will be a 7. It's a weird looking y. So how are you going to write that as a log? Got to be really good at them. You start with log, and then you think, what's the base? What feels like the base? X. And then what's the next thing? Is it the y? No, you got to jump around. Over there, and then back. The circle of logs. So this one, if I rewrite it, it's solved for y. Do you get how y is alone? It's log base x of 7. Okay, so that's the basics. I wanted to make sure we were good enough with that before I go here. Here's the 3 kind of equations that we will ask you to solve. Sometimes there's an x in the base, like that. And guess what I have you do? You rewrite it. Everybody rewrite that one. It's x to the third equals 8. Do you get, you could solve that? All right. So I want you to do the same thing for this. Rewrite this one. That one has the x. That's called the exponent spot. You'll see why when you rewrite it. Rewrite the middle one. Did you make it 2 to the x equals 8? Now, in a way, that one got worse. This one was better because the x was alone. You know, it isn't always better to rewrite them. Sometimes they get worse. Now, maybe you like to solve them that way. 2 to the what is 8? Oh, yeah, it's just 3. But you could have solved this one in its original form if you knew that 8 was like 2 to the third, and then you could have known the answer was 3 also. All right, and then the last one, rewrite that one. Jack, what'd you get?
2 to the 3 equals x.
Good. Is that better?
Yeah.
Yeah, because x is alone, and I can just do 2 to the third in my head, and it's 8, so I know x is 8. All right, so those are the 3 places they can hide the x. And from there, you just have to solve these little equations they give you. And of course, they get more complicated. So on this one, Is it already solved? Is x alone? No, then your first thing you want to do is go and rewrite it. See if it'll be solved then, or if it'll be easy to solve from there. And that is pretty easy to solve. I can do it in my head. What's x equal to? 2. So your first thing you do is you rewrite it, and then you see if you can solve it. Now, could I put this to the 1/3 power? Yes, but that's kind of making it overly complicated. If you just realized that x had to be 2, that'd be good enough. Okay, this next one. I don't like writing fractions like this because then the root is on the bottom, doesn't really make any sense. So when you do it, you go x to the 3/2 power is equal to 27. And then hopefully you'll remember how to solve that. Miss Janes, can you tell me what power I'm supposed to put it to? 2/3. Is that the kind where I'm going to have an absolute value and get 2 answers? No, because it's got an odd on the bottom. So that just cancels this, and yay, I just get 1 answer. Can you do it in your head? Jack, what's the 3rd root of 27? And then square it?
9.
Yep. Who had 9 before he even said it? Okay, awesome. All right, see, these aren't that bad if you understand logs. Now, they're going to make them more and more and more complicated, but always comes back to can you rewrite it? So Tate, can you rewrite this one with the red x minus 4 as the base?
X minus 4 is 3/2 to the power.
To the power of 3/2 equals?
8.
Good, and then I'm going to put it to the power of?
2/3.
2/3. Is that the kind that's going to cause 2 answers?
No.
No? So then that cancels that, and I'm left with x minus 4 equals 3rd root of 8. 2 squared? 4. And then I'm going to add 4 to both sides. X equals 8. So I'm reminded of the dentist saying, which teeth do I have to floss? And the dentist was like, well, only the ones you want to keep. Which answers should I check? Only the ones that you want to be sure are right. If you're doing your homework and it's not that big of a deal to you if you get one wrong, you don't need to check it. But do you get that if this was a test question and you only have like 8 test questions, you could have 1 easy one wrong and 1 hard one wrong and still get an A. But if you make any more mistakes, it might be worth it on a test. We only have 8 questions. Just check it. So let's just check this one quick. Act like it was a test, and we're going to check it. Log base 8 minus 4, which is log base 4 of 8 equals 3/2. It's not just like immediately telling me, oh, this is right. But now if I go 4 to the 3/2, it should equal 8, right? 4 to the 3/2. Ooh, I can do that because it's the square root of 4 problem, really. Square root of 4 is 2, and 2 to the 3rd is 8. It works. I checked it. I know it's right. Not every test is like this, but this is one of those tests where you can take your answer, which we figured out was 8, and stick it back in the problem and make sure it really works. Especially important becomes sometimes it doesn't. And then it's called a what kind of answer? Extraneous. Extraneous is where there is an answer, but it doesn't work. Undefined is where there is no answer. This had an answer for sure. I just was checking to see if it was extraneous or not. All right, on to this one. 1/2 to the x equals 32. Is that any better? I feel like it's worse. So sometimes rewriting isn't just the magical cure. On this one, if I could only make the 32 be 1/2 to a power, I'd have my answer, because then the bases would be the same. So that's the way I would do that one, is how could I make 32 into 1/2 to a power. 32. I'm going to make it into 1/2 to the... How do I get 2 to be a 32? 5th power. So, -5th. That'll make my 1/2 flip over and go to the 5th power. And now I did all the hard work, so now that the bases are the same, the answer is just x equals -5. Would you have rather instead made this have a base of 2 and this have a base of 2? We had a test like that. You remember that test? Where we didn't know logs yet? And we could have made this 2 to the -1. And this could have been 2 to the 5th. And then you could have solved it that way. And guess what? The answer is still the same thing. It's -5. -x equals 5. There was a negative I just drew over there. Careful with that. And so x equals -5. Either way, x equals -5. Just showing you lots of options and ways you could solve them. All right. This one, see this little calculator up here? That indicates, I don't want you to grab it right now. I think it's a waste of your time. So we're not going to go grab them right now. But we're going to get to the part where you need the calculator, and then we'll just stop. And of course, you know how to type things in the calculator. You could do that. That'd be easy. So tell me how to start, Catherine.
The way you want to start is with 3x plus 1 in parentheses. It says it's equal to 5, then put it to the power of 5.
Yep, you're doing good.
239.
You are correct. Now, am I to the part where I have to have a calculator? Well, kind of. I just at least could say what I would do next. Jack, do you know what to do next?
Put it
To the 1/5. That part is easy, but I'm not going to be doing that in my head anytime soon. But I'd just get a decimal for that, and then I'd subtract 1, divide by 3. It'd be pretty easy from there. All right. Now, notice, no calculator. They're trying to show you that there will be some that could have, this might be our first test where we will say, you get a calculator for this part of the test and no calculator for that part of the test. I'm not saying that's how we will do it, but I know we do that in our honors pre-calc classes a lot, where it's like, for this part of the test you can have a calculator and for this part you can't. Or for this chapter we get a calculator and for this part we don't. So, try to do this with, I know you might think, I wish I had the calculator, but you can do this as long as you know things like the 5th root of this or the 3rd root of that. Simone, tell me how to start rewriting this one with the, right here.
The base is 5.
5 to the
2x minus 6.
equals
125.
good. Now, do you get that this is that kind where you could make the bases both be 5? That's the hard part. If you could use a calculator, you just get a decimal for that. But frankly, if you could use a calculator, you would have gone and put that in the calculator and got a decimal for it. And then you could just add 6 and divide by 2. So if this, the challenge here is that there's no calc. All right. Kate, what do you think is the next step?
You can change 1 over 125 to 5 negative 3.
5 to the -3rd. If you get stuck on these like I do sometimes, just try to figure out how to get 5 to turn into 125. And that's to the 3rd. And then you just figure out how to handle the fraction. Oh, that's the negative. So 5 to the 3rd, then make it negative. Nice. And now, there is my equation. That should be pretty easy from there. Brody, you know what to do?
Plus 6 is 3. And then
Oh, wait. First rewrite that. 2x.
minus 6 equals -3.
Yep.
And then plus
2x minus 6 equals -3. And then add 6. 2x equals 3, and then
Divide by 2.
by 2 divided by 2, and your answer is 3 over 2. But did you check it? Pain in the butt, but I'm warning you, there will be some, and it's likely to happen on the test too, where you did it all right, but that answer doesn't work. It especially happens when there's square roots involved. Now, I didn't have any square roots involved in this one, except at the end, if this was a power, then it's a square root power, and so maybe I should check it just to be sure. 3 over 2. And then those 2's would cancel, and then that's just 3 minus 6, which makes negative 3. That whole side becomes negative 3. And now is 5 to the negative 3 actually 1 over 125? And it is. Yay, I checked it. It worked. All right, on to the next page. It's yellow. Get to that page. Calculator's back again, if we were going to take one out. And if we were, I'd just put that in directly. Now, the problem with that is that some of you know how to put, some of you have the new software, which is really cool, and you go math, alpha, math on your calculator, and then it just pops up. If you type those 3 buttons, it'll pop up a log with an empty spot here and an empty spot here, and you just put in what it says. Like here, the 8 is here, and the 1/12 is there. Wait, don't grab your calculator. Just listen. Some of you don't have that feature, and so this is a moment where I have to tell you something about your calculators. Let's keep it simple. Log base 3 of 4. It's some number. Not sure what it is. If I want to figure it out, I go like equals x, and I say 3 to the x equals 4. And then I think, well, 1 would be a little too small, so it's probably a little bigger than 1, so it's like 1.2. But you would actually get that from a calculator. So you either have the kind of calculator that's going to be able to directly, you can just put these in the little boxes, or you have the old kind. I do want to figure that out at this point. So grab your calculator, and let's see if you can put that in your calculator directly, or if you've got the old software, which means I got to show you another way. If you want to borrow one of mine, you may. You just have to give yourself a whisper. The buttons are all exactly the same. If you're insisting on doing it on your iPad, I'm okay with that, but you better have it up on your iPad.
How do you get it?
And then you have to log into SSO. Might be easier to just borrow mine. I do have one more.
Oh, is it?
Let me put the keyboard back on. It's working. Okay, so let's see. I have the new software, so I get to say math button, alpha button, math button. Math, alpha, math. And these 2 little boxes pop up, and I can put a 3 there and a 4 there. Let's do that. If you've got that software, yay for you. It's easier. And you get 1.26. I'm rounding. Raise your hand if yours is that way. Okay, cool. If you don't have that kind of calculator, then you have to type this. Log 4, and you hit enter, divided by log 3, and you hit enter, and then it should say 1.26. You have to divide the top divided by the bottom. And I know that's weird. It's in the opposite order that you would normally do it in because you read from left to right. You would think you'd have log 3 on top, but you do not. So at this point, you should have 1.26 up on your calculator, whichever way it was. Whether it was the easy way for you or the hard way, you should be able to get it to 1.26. Would you please compare with the kid next to you and verify that they have 1.26 on their calculator, because otherwise they need your help.
I know.
I did it.
Show me yours. Good, thank you. All right, so that is called a base change, and it's actually, like, it kind of blows my mind. This is base 3. These kind of don't have a base, which means that they really have a base of what? Remember what base you have if you don't say what base it is? No, base 10. If you didn't know that before, if you just hit the log key, you're not saying a base, that means you're doing base 10. So this is what's called a base change. This one, would you agree it has a base of 3, right? But yet, when the kid types this into their calculator, they both are in base 10. So that's called a base change. Now, I know some of you are thinking, well, I don't need to know that because I got the good kind of a calculator. You all need to know base change. Here's why. On the test, we can say log base 7 of 5. Change this to base 3. And I know most of you are like, I have no idea what you're talking about. Well, start by, what would you type into the calculator if you didn't have the cool kind of calculator? You would type log, what goes on top again? Log 5 over log 7. And here's the crazy part. You know how they were base 10 before? It could be base anything. You could pick any base you want. If you want it to be base 9, voila, they're both in base 9. And it'll be true. It'll still be equal to this one. And you can pick any base you want. I know that's weird and complicated, but the way I'm going to try to explain it to you is this. If I use base 9 and I get the answer, it's like both of the numbers on top and bottom are proportionately smaller than if I had used base 10. They're proportionally now both a little bigger or smaller than they were, but they stay in proportion. Okay, so moral of the story, if you want to do a base change, you have to know that little process that I just showed you there, and that is an ACT type question. It doesn't give the kid with the calculator an advantage either, and the ACT is big on that, and I respect that. They want to make sure that a kid who doesn't own one of these fancy calculators doesn't have a disadvantage. So they ask questions like that, where if the kid has the calculator, sure, they can type it in quick and just get the answer, but the kid without a calculator, there's no way they're going to be able to get that decimal. No kid without a calculator can do that in their head. But they could do this without a calculator, change the base. All right, so let me give you one more to see if you really got that. Log base 4 of 9. I don't want you to tell me the answer. I want you to change it to base 11. Remember, the base can be anything. Should have started with log 9 over log 4. And the standard base would be 10. But we get to pick any base we want. So we just make them both base 11. And now my problem is in all base 11. You guys get that? That's how you change the base. And again, once you've written the black part, you could put any base right there. They have to be the same as each other. But that's like scaling both of the numbers to be a little smaller than each other, than they were. And the proportion stays the same though. Okay, good enough on that. Now you know how to do a base change. On to the next page. Everybody get to this one. It looks really complicated, and it says no calculator. Well, actually, it means that it's probably pretty easy if you know some things like the 4th root of 16. This isn't going to be that bad. The 4th root of 16 is 2. And then you put 2 to the 2 to the power of 1, and it's still 2. Now it's negative, so it's negative 2. So all of that, just negative 2. Then you do your rewrite thing. To the power of negative 2. And it goes goes over here, and then you got to come back here. Equals 3 to the negative 2. Now wait, I know what... Just a second. If they're both to the negative 2 power, can't I just cancel that off really quick by putting them both to a certain power that'll make that negative 2 go away? If I put them both to the negative 1/2 power, that'll kill off those powers. And then it's just x minus 3 equals 3. Because see, that and that make 1. And then add 3, final answer, x equals 6. All right, not gonna lie, these are kind of complicated and there's a lot of algebra. You almost have to be an algebra ninja to be able to figure these out. X over 2 to the 4th equals 16 over 81. Ooh, I smell a simplify. I bet that there's going to be some way to simplify this, because that's 3 to the 4th, and that's 2 to the 4th. Because see, 16 is 2 to the 4th, and 81 is 3 to the 4th, and that's like 2/3 to the 4th. Now I have x over 2 to the 4th equals 2/3 to the 4th. And if you're like, I would have never seen that, well, then maybe you wouldn't have got this one right. You got to look for those. 16 was 2 to the 4th. 81 was 3 to the 4th. And now, since they're both to the 4th, I can put them both to the 1/4. And x over 2 is equal to 2/3. And from there, it's easy. You just clear the fractions. My favorite thing is if you can factor it, you should. My second favorite is clearing out the fractions, because it makes complicated problems easy. Doink. 4/3. If my life depended on it, I'd check it. Yes?
Since it's even, would it be plus minus?
Ooh, let's check. So if I go back, I just did this step right here. It would be if the root was even. I did not put it to the 1/4. Oh, wait. Maybe it is. Hold on. I had to put this to the 1/4. Ooh, you might be onto something. And that means absolute. Oh my gosh, I think you might have caught me. 4/3 would have been my answer, but it might be plus and minus, because look, there's an even root on both sides. But, oh, it's one of those dumb ones where I would have got credit, because the negative 4/3 doesn't actually work, because look, I can't put a negative right there. You know what I mean? So you got me. I should have noticed there was 2 answers, but one of them, the one that was negative that I forgot, it didn't work anyways. So the reason I had an even root that I didn't show, and so I didn't even think about it, and that meant I had 2 answers, plus and minus 4/3. And that means that I should check and see if one of them might not work. And yeah, the negative one doesn't work, because when I put it in, can't have a negative in the base. So the negative one is extraneous. This one still works though. Wow, these are getting intense. Hey, you signed up for honors. You know your life would be so much easier if you're in regular. But you wouldn't be as well prepared for next year. I think a lot of you guys are going to take the honors version of, or the AP version of pre-calc. You would not be ready. Regular HA, oh my gosh, that would be almost impossible to go from regular HA to AP pre-calc. That'd be almost impossible. All right, so this one, no calcs. Let's see if you can do these two without any help from me. I'm going to pause for a second. I might try these two that are on the green page, no calcs. If you have some things memorized like that is 4, your life's a lot easier. X equals 4. Raise your hand if you had that one right. Okay, cool. The next one, x to the power of 1/2 equals 5 over 2. I strongly recommend you not write your fractions diagonally, but I get when the teacher typed it in there, I know the program that they're using, and it doesn't allow you to write fractions like vertically. But since you're writing them by hand, you should write them vertically. All right, now I'm going to put it to the power of 2, to the power of 2. And that cancels that. Power of 2 does not give me 2 answers. And now my answer would be squaring both of those, 25 over 4. Raise your hand if you had that one right. Cool. All right. Now, I feel like we're just getting to the point where it's like the same thing over and over again. So I think we should just get into the homework. So let's get to the homework, everybody. And I'll tell you which ones to do and skip. Awesome. Can you scroll up so I can see the beginning of it? All right. Awesome. Can you scroll down so I can see how many there are? All right. I think we're going to skip. We're just going to skip 19 and 20. Actually, I can skip a couple more in that upper section. Can I see in the upper section? 9, 10, 19, and 20. Skip 9, 10, 19, and 20. There's some symmetry there. Okay. Numero uno. I know some of you already started, which is cool. I'm good with that. As long as you were doing the problems I was giving you along the way. Miss Long, could you read me number 1? Base. Log base x? Okay, log base x. Thank you. And then I rewrite it as x squared equals 36. And then I go to the power of 1/2, warning, power of 1/2, warning. I am putting it to an even root. Do you get there will be 2 answers? Absolute value of x is 6. That means 2 answers. X equals 6, x equals -6. If you forget that, like the teacher did who made the key, then you have to go back and remake the key and go, oops, that one doesn't work. It's an extraneous answer. Now, can you just skip all of that? No, that implies you forgot there was 2 answers. You have to show both answers and then cross off the one that doesn't actually work. And if you're wondering why it doesn't work, because you can't have negatives in the base. All right. So, I want to give you a bunch of time to work. I want to give you a chance to come up and ask individual questions. So if I stop now, then you'll have time for individual questions. And that's all I got for you for today.